right, let's get buck wild. So just want to set some audience boundaries real quick. Leave all corrections, comments, any questions you got until the end of the talk. If you have one, note the slide number in the bottom right corner. It's a very large number. Can't miss it. You can also tweet your question to me with the hashtag 123gotaCPP. And I'll just look for that tag afterwards. So if you have like questions that we couldn't get to, feel free. And this is also for anyone watching this at YouTube at home, so you can actually tweet at me long after this talk has been done, and I'll try to answer your question if I can. Some more boundaries. Any question I ask is going to be rhetorical. Don't answer them. Don't interrupt me to correct me either. This is a common thing that happens at CppCon where someone says, well, actually, I want to be pedantic right now. Don't do that. Because if Git and the Texas Board of Education can rewrite history, so can I. For the viewers at home, if you could please take your hand off of your face. Don't take weird Dutch angled screenshots of your monitor while you're watching this and then tweet them to me. Don't take pictures of your favorite candy and tweet them to me. And don't build a digital altar to chorizo in VR and then send me an itch.io link to that. Or a picture. And definitely don't do any of this stuff while listening to Rage Against the Machine. So just a quick overview. I'm not going to rant about build systems. There's almost no code. There's absolutely no graphs. So if you're here for like those hard crunching numbers, you're in the wrong place. Build systems are a lot like the best weapon from Turok 2. They're a cerebral bore. And so this is not a talk about like how to use modules, every existing C++ build system, because I don't want to be here until the heat death of the universe. And it's not about which build system is best, because they're all garbage. And every build system not written by me is garbage. You can quote me on that. So several recurring themes in this talk. There's this thing I like to call the project layout Ouroboros, which is a snake in its own tail. I'm also going to mention how build systems are affecting the design of C++ and how that's not how it should be going. And excuse me, we're going to talk about the sweet treats, the milkshake, if you will, of other language ecosystems. We're going to hit a huge number of subjects, though. There's a lot of like intersectional stuff that comes into being with this stuff. So some opinions or options might be skipped, so I can't really get to everything because this is like a 2.5-hour talk that I have to condense down to an hour. But generating discussion is more important. And also, I'm not going to rant about build systems. All right, so who in the Sam hell am I? Hello, I'm Isabella Muerte. I'm a C++ Bruja. I'm a build system trash goblin. A little bit about me, I'm self-taught. I care a lot about build systems. Because I taught myself to program by writing a build system. I don't recommend that you do this. You will be punished for your own hubris if you do. I like burritos a lot. Just a little tidbit. Anime was a mistake, and I watch it all the time. So that's my Twitter, that's my GitHub, and this talk is really about build systems. Hail Satan. All right, so a little bit of history. So in the beginning there was make, there's other stuff too, but there was make, right? And it was fine. If you've used the original make, you're like, oh no, this was cool. Why did this get upgraded over the years? And the problem with modern make, there's quite a few. It's which one are you using? Because there's GNU make, there's BSD make, there's NMake, and by NMake I could mean AT&T's NMake, I could mean Microsoft's NMake, I could mean Nokia's old NMake. There's a lot of companies that like to name their thing NMake, and I don't know why. This complexity of make files, because our builds get complex and you want to do things, and make is just a simple task runner with dependency checking. It always leads to these configure scripts, so you end up having to write and maintain two systems. No one is satisfied with just make. And eventually everyone tries to reinvent it. Eventually, you've probably seen cake and bake and yake or whatever, something ending in AKE in some manner, right? And 99% of the time, they fail miserably. That other 1%, by the way, is Ninja. And it's like, I'm not Make, I'm my own original build system, Blake. How embarrassing. So Make's biggest problem, tabs, right? Obviously. Duh. It's like every episode of Mobile Fighter G Gundam. A mistake. My shell is calm, but this build system of mine is burning red, shiny Make file. Okay, so Make's actual biggest problem is that it assumes and expects a C-style compilation model because it was written for those types of tools back in the 60s, the 70s? I don't know. I was born in '89. I'm way younger than that. And so tools are written to be used with Make, and they mimic this approach, and it's usually a huge detriment to the tool itself. So let's get into the current C++ build ecosystem, because there's a lot here. So there's all the Make replacements: Ninja, Sconce, Bazel, Buck, Shake, which is written in Haskell and uses Haskell definition files. So if you don't know Haskell, you're not going to have a fun time, but it can execute Ninja files. There's also a Wu-Tang build system that's being worked on, but I will never reveal the Wu-Tang secret. So there's meta build systems, CMake. We all know CMake. We all know CMake. There's Meson, which is actually the least terrible. And actually, I made a tweet before this talk about how I was going to talk about how build systems are bad. And the author of that responded with challenge accepted. So that's going to be a fun conversation later. There's Premake, which is written in Lua, so we're not going to talk about it at all. And there's Auto Tools. Auto Tools. The Mitch McConnell of build systems. That man is a turtle wearing a human skin suit. All right. So like the problem with these meta build systems that we have is that they're typically undebuggable, right? They have this domain-specific language. That's what DSL stands for, by the way, if you're not familiar with that. TLA. TLA, by the way, is a three-letter acronym for a three-letter acronym. They assume you know what you're doing, and let's be honest, you don't. They're filled with esotericism and black magic, which is fine if you're a witch like me, but if you are one, you're not going to work in tech, and you're certainly not going to touch CMake. And so the typical meta build system experience can be summed up, I think, with this image. Yelling intensifies. But then eventually we all learn to accept our fate, right? And we're just kind of call for help, but, you know, whatever. Dougie Jones. So just a quick overview of package managers. This talk isn't about package managers. That is a nightmare I don't want to talk about yet. But we've got Conan. They've been here. They gave a couple talks, I think. They're fairly well known. Spawned from B code, rest in peace. I like anything that uses Bs or hexagons, as you can tell from my massive tattoos. There's Hunter, which is CMake based, and that has a majority of upgrade issues because if you want to upgrade Hunter, you have to go through all of your dependencies that are using Hunter and upgrade it. And like I've heard some people say, you know what would solve this is if we had a package manager for CMake scripts, and that sounds like the worst idea in the world. There's also Build 2's V package. I didn't mention Build 2 earlier because it is also a package manager system. The author of which is here at the conference, and I've spoken with him face to face, so I feel like really intimidated about like shitting on his work. However, I think he does some things wrong, but that's because every build system does some things wrong, and we'll get into that in a bit. So the project layout Ouroboros, I mentioned this at the beginning of the talk. So I'll just give you an example. So you've written a build system, right? And it's good. It can build things. Because a lot of build systems out there can't build things. It's very strange. And it's like, congratulations, that's really hard, right? Like, it's difficult. I've done it twice, and I regret the decision both times. But you have a better chance of making a movie titled Steve Buscemi's Antifa Rodeo. Bash the fash, my fellow cowpokes. And so, like, you want to tell the world, right? So you're like, I'm going to post this on the C++ subreddit. What's the worst that can happen? Careful, Icarus. Because the first comment reads, I'm going to actually look at the computer for this because it's going to be a lot of text. It doesn't support my current project layout. I won't use it unless it does. Also, why is it written in language? Why isn't it written in a different language? Seems like a waste of an opportunity to get more people to work on it. There doesn't seem to be more than one developer working on it either, because you've been working on this on the weekends and when you have spare time. What assurance do I have that you won't drop support for this built system if something better comes along, or if you have a kid, or if you get a new job, or you just get tired, or you die? Right? That's actually one thing that people don't ever talk about with open source. Like, what happens when you die? What happens to the copyright of that project? Not part of this talk, just want to put that out there. This tool is bad, and you should feel bad. Everything you've ever done is garbage. No one will use this tool because no one is already using this tool. And you need users to get a build system off the ground, and you can't stop CMake because the community has chosen it as the best build system out of necessity. Not because CMake is good, but because everyone uses CMake, so you should just give up now. I do briefly want to say, this is paraphrased from a bunch of comments that people made when Meson was first announced on the C++ subreddit. Of course, 9/11 was an inside job. Obama turned my frogs gay. And this is someone who's never going to use your build system anyways. So it's like 3 days have gone by. Like, you're depressed, right? It's on the 5th page of the subreddit. Imposter syndrome is setting in. You're like, oh my god, I'm a fraud. Like, why did I spend so much time on this? This is the thing that happens. You put a project out, people shit on it, and then you feel like garbage afterwards. Unless you're, I don't know, like, you have a huge ego and you're like, nah, I got this. Right, but then you notice someone made a second comment because they're ready to troll you, but they also want to give, like, constructive feedback. Bounce on my boy's build system to this. 11 out of 7 will use again, and this is posted by XXX420 Lone Wolf Builder 69 XXX. But this is good news, right? Someone used your build system and they aren't you. Right? Like, you're Tron now, right? Like, you're fighting for the users. So you're like, I need more users. Right? Like, you don't want to just have one user for the rest of your life. That's just weird. So you redesign your build system for existing project layouts. Careful, Icarus. You just committed the cardinal sin of design, of, like, engineering, be it software or otherwise, architecture, everything. Anything that involves design. Because the function of your build system follows the form of existing projects. I don't know why this is not working now, but it was earlier. Anyways. Your build system needs to be like the baseball field and movie field of dreams. I'm going to say this right now. Every build system, you need to treat it as if it's good enough, people will use your build system. Don't, I don't know how to pronounce the word correctly because I've only ever seen it actually written down. I'm one of those people. Kowtow? Kowtow? Yep. Thank you. So don't kowtow to their demands if it's like you're sacrificing the form of this. And I'll give more examples of this later in the talk. So we've covered like the basis of like what that is, because this is the project layout Ouroboros is you need to support existing project layouts. So you have to support every project layout, which means your build system has to be able to build every possible thing, which means if you write a new build system, you have to support every possible project layout, which means we're just in this endless loop of just hell, right? And so build systems also affect our workflow. Like, they affect how we get stuff done. Chandler Carruth actually made an interesting comment last night when we were all kind of talking in the hotel. And he said, like when my engineers get a better build system, it doesn't improve their performance, like getting stuff done. But there's a small implicit thing, because this is something that people like to apply to a lot of things. It's not, this is how it is, like, oh, every developer team will work like this. It's, for Google, using a newer or simpler build system is probably a detriment to their needs, because Google makes billions of dollars every year. And I doubt that everyone here works at a company that makes as much money as they do, or uses as much data as they do, or has a monolithic repository as large as they do. But our build systems do affect our workflow and our projects, right? Because if your build system says you can put your stuff anywhere, then you're going to put your stuff anywhere. You'll put it like 3 or 4 directories in, you'll have source, and then inside of that you'll have project, and then inside of that you'll throw all the .h and .cpp files because you're using Qt and you're also a monster. But there's some language features that build systems don't take advantage of, or they prevent us from taking advantage of, and one of these is extern template. So it was added in C++ 11. It existed as an extension between GCC, Visual Studio for years. By the time Clang came around, it was like, this was already added to the standard, so it didn't really matter. It had been voted in, I think, in like 07, maybe even earlier. Someone can fact check me, I don't care. It's extremely useful when used correctly, and it's really hard to use it correctly because the whole point of extern template, which I'll show, is that it prevents you from instantiating a template every time it's a template. And it's basically a way to help the linker speed up. And it's super useful for LTO or LTCG, whichever link time whole program optimization thing that you're doing. No, I put that in as a bullet point apparently, and I forgot. But it's fairly advanced, right? Like it has a very specific use, and it's super limited in what you can do with it. And it's also not publicly used or discussed much. Like I went on GitHub, which is like, that's like the Facebook of open source code at this point. And I just did a search for extern template all as one string because they've kind of fixed their search engine finally, where you can search for multiple words in a row. And the only projects that used extern template were either small weekend projects that had been abandoned 5 years ago, which meant that a little after 2011, that person would have gotten access to a compiler that supported C++ 11, and tried it out and was like, okay, cool, I guess that's useful, and then moved on with their life. Or it was just like a project with 1 star that hadn't been touched in 3 years. I didn't see any big name C++ projects using extern template. And some people have been like, well, we actually tried that out, we didn't find a huge performance boost, but it's actually for mostly optimization. The most important thing is that in our current ecosystem, because modules aren't here, is that they're best used with precompiled headers. Everybody loves precompiled headers, right? No? Okay. So they're not part of the standard. They're never going to be part of the standard. Like, Brianna would probably like flip a frickin' table and be like, just like, get out. But it's supported by the compilers that matter. Visual Studio, NCC, Clang. I think Intel's compiler supports it. It's extremely useful when used correctly, and it's poorly understood, and also not perfect, but it's not great for every organization. Like, by organization, I mean every company. You have a huge code base where you're constantly modifying low-level libraries that everything depends on. Yeah, probably not a good idea. But if you're using third-party binaries or libraries that you're not going to touch often, probably use a precompiled header. But the problem is that no build system uses them or supports them correctly. None of them do. All the big ones I mentioned earlier, none of them support this stuff correctly. Meson gets kind of close, but it doesn't support more than 1 PCH. And no build system lets you choose when to include them. Meson force includes it into every file in your project. You're probably like, wait a minute. Why would I ever want more than 1 PCH? Well, you get better organization of third-party libraries. SQLite 3 is one of my favorite libraries. It's small, it's like condensed, it's 2 files, but those 2 files are an almost 2 megabyte header file and a like 4 or 6 megabyte C file. I'm probably wrong with these numbers, but they're huge, right? And if you're not using Clang, you're going to choke on that header. And every time you have to include that header, it's more cost. So if you want to just precompile SQLite 3, great. And do you really want to have it available in every header? Because what's happening is if I want to use SQLite 3, I have to put it in my precompiled header for the project, where I'm also going to put, probably std vector, std string, and memory, and all the other library, like standard library stuff that I'm going to be using. Do I really want that to be available everywhere? No, it's dumb, right? You want it only inside of your CPP files, not inside of every header. So a smart build system can also technically generate your PCHs for sub-projects or dependencies, but that is a super advanced thing, and we don't even have our build systems able to do that in the first place, so I'm not going to give you an example. We'll never know, right? It's like the old Tootsie Pop commercials. How many PCHs does it take to get to the root of a Tootsie Pop? 3. We'll never know, So I'll just give a quick example of it. This is the only code you're going to see in the entire talk. So we got file.cxx, and that's very small. I'm sorry. But there's a reason for it. It's because when you do extern template, you can't rely on what the actual declaration that you're using is. Any type defs, any template aliases, it basically says no. You have to write this out the whole way, which if you're using stuff like meta template programming and you're using it as like a conditional inside of the class, you have to write it out for each possible instance. This could be better, but no one wants to make it better, and honestly, people don't use it that much in the first place. Maybe if our build systems get better, they will, and we can improve this. But in file 2, we physically instantiate this template. So inside of file.cxx, this is for std string, by the way. In file.cxx, I say I'm going to be using std string. It's able to still check and make sure everything's kosher with its command line, with its function parameters and the type system and everything like that. But it doesn't actually generate any code in that C++ file. It's going to create a bunch of stub functions that say we don't know where this is. And this is actually like a more efficient way of doing inline functions effectively. What you're saying is, instead of saying here's 10 inline functions that are all the same, linker choose one and order this the best way, you're explicitly stating to the linker and to the compiler, this is the one instance that we want to use. And you do that by just removing extern from the front of the class. And this generates every possible member function inside of this .o file. So if you're doing this like for a DLL, maybe don't do it. But if you're doing it for static library, it's super useful. But if you place the extern template thing over and over and over, it gets really exhausting. And putting it in just a header isn't really useful. So we're going to place this into a PCH. So inside our PCH, we've got the good old header guard. Pragma once in there, so the people that complain about, like, oh, Pragma once is faster, can just shut up. We include a bunch of standard headers, including CISO 646, because in this, the year of our Goku 2017, Visual Studio still does not permit and or and not as keywords by default. And they're defined in that header, which is technically against the standard. I'm not bitter. And then we have our extern template here. And we precompile this. Like we have a pch.cxx file, and we've placed the template class instantiation there. This works perfectly fine for Visual Studio, where you need to include your PCH into a C++ file so that it actually compiles it. And if you're using Clang or GCC, your code base doesn't really change, because if you're using GCC, Clang, and MNMLSTC, you get the same behavior more or less on its command line parameters between all of them. The precompiled header, the .o file, everything's good. The problem is that if you want to start adding, there we go. Problem is that our build system is forced every file to depend on our PCH, because no build system lets us choose when to include them, which I mentioned earlier. And any changes we make to add extern templates require changing this file. So we want to improve our linker time, so we have to modify this PCH. And we're constantly recompiling everything. We cannot make multiple PCHs where we can say we only want to instantiate these templates here, or here, or here. And so control's been taken away from us. And if there's one thing C++ programmers hate, it's being told what to do. There's a reason I was playing Rage Against the Machine before this talk started. And extern templates and this one PCH approach is a huge pain to use. So we don't use either. So I'm going to just switch targets real quick, because I just also want to remember, this is like, there's a lot of stuff here, and I need to get you all caught up to speed on like a lot of these problems. So we're going to get started with C++. Like you've got a brand new machine, or you're coming from another programming language and you want to get started with C++. Or maybe you've been writing C++ at work, you're on C++ 03, you don't really use it at home much, and you're like, I want to learn these new features, right? So this is the hill I'm going to die on. The massive fragmented ecosystem is what makes C++ a so-called experts language, right? This causes more pain and suffering than the actual language itself, I will argue, and die on a hill for. Because there are 7-year-olds writing and using C++. Sarah Chokes is here at the conference, and she's given, I think she may have already given a talk on Joule bots tomorrow. Thank you. So there's a talk tomorrow talking about Joule bots, which she made for kids so that they could learn how to program and their children. and they are writing C++, using C++, and very recently I saw some of them giving a presentation on C++. So whenever I see comments on Reddit of like, C++ is very hard and I don't get it, I get concerned. But it's because their ecosystem, these kids, their ecosystem's taking care of it for them. Like, they don't have to worry about what compiler they're using. They don't have to worry about the IDE. They don't have to know anything about make files or CMake or any of that garbage that just pollutes everything. So here's an example. Let's get started with Haskell, right? I don't know Haskell. I don't care. But to get started with it, you download the latest version, you install it, and you can start writing Haskell right then and there, right? And if you need to use stuff, you can use Stack. It used to be Cabal, I guess. I don't know. To compile your code. I did a quick Google search, and this is how I found this stuff. And you can use it to manage your dependencies. So let's get started with Rust. Everybody knows Rust, right? There's Rust programmers here too. Rust is what made me want to write this talk. Like, it made me depressed after this happened. You download the latest version with their tool called Rust Up. You install it. This is all in one step, by the way. And you start writing Rust. And then you use Cargo to build your code and manage your dependencies. So let's get started with Python, which is a dynamic programming language, right? It's got to be different. Different steps, surely. Okay, you download the latest version, install it, start writing Python. And then you set up tools to compile your code. It's different. Because they also have pip to manage the dependencies. But setup tools is actually just a library that pip uses. Let's get started with Node. I think you all know where this is going, right? You download the latest version, you install it, start writing JavaScript. Or, if you just want to write JavaScript, you open your web browser and you start writing JavaScript. They do have a bit of a fragmentation issue at the moment, though, because you use NPM to compile your code. Say compile because the browser does it for you. But I guess you can also use Yarn or Bower or Webpack, I think. I don't do front-end development. I don't know any of this shit. I don't care. But let's just go with NPM, because having a default is better than having nothing. So let's get started with an international standard language, Ruby. Did you know it was an international standard? Probably not. You download the latest version, install it, start running Ruby, and you use Gen to compile your code and manage your dependencies. I'm a broken human being when I see these slides. Like, I got really sad as I wrote them. I had to take a break for a few days to write these slides because I was like, holy crap, that's worse than I even imagined. Right? Because you all know what's coming. Every single person in this room is here because I write C++. And for you, the viewer at home, maybe you don't write C++, but if you do, you know what's coming. See you. Get your hand off of your face. I already told you. You can't stop this. Like, this talk has to continue, right? We can't just like be like, that's it, I'm out. Like, you can all leave, but I have to stay here and go through this. Let's get started with C++. What compiler do you want? Sorry, excuse me. What operating system are you on? Let's assume that you're on the most popular operating system. Haiku, I'm kidding. Windows. Because that's the most common one. And while many of us might be, well, I got my start with Linux or Mac, most people are on Windows. And many people that are coming from a lower social or economic state are probably going to be using Windows because that's what everything frickin' comes with. They can't afford Macs, and they don't know what Linux is or how to install it. So what compiler do you want? Well, if you spoke to Chandler Carruth or anyone else, really, I would honestly say start with Clang, right? So Clang for Windows has a problem because to use it, you have to have Visual Studio installed. And if you don't know how to install Visual Studio, you're going to have a rough time. The Clang install is really easy. You double-click it, it installs. Simple. Visual Studio, you have to sit there and wait for it. You have to choose between 3 editions, Community, Enterprise, or Professional. Not in that order, by the way, for the cost of each of their SKUs or whatever they're calling it over there. There's also a secret hidden 4th one, which is this Build Tools. That one's my favorite one because it doesn't install all the other garbage like .NET or the JavaScript stuff. I don't care about any of that. So we're going to go with GCC, right? But GCC on Windows is also a desecrated land of just like pain and suffering. So we've got the STL distribution from Stefan Lavalwade from Microsoft. He runs one on his website. That one's the best, but it comes with a lot of stuff. And if you get used to that stuff, you're not going to be like able to move to other environments. There's also the problem, of course, that his choice of error handling and threads affects it. There's TDM GCC, which is always out of date. I put sometimes it's always been out of date. I went back and used the web archive thing. And then there's also a zip file in some random personal directory from the MinGW64 project. You're like 3 or 4 directories deep until you find this thing. And then when you get there, you're presented with some options. What exception handling do you want? Do you want structured exception handling, which is what Studio uses? The GCC was able to reverse engineer, but then Clang had to also implement their own implementation because they don't want to have any GPL code in LLVM. Or do you want to have SJLJ? SJLJ, by the way, does not stand for Social Justice Lich Jezebel. That was a stretch of a joke, and I searched for hours on Google to find a word that could end with J. But we're going to go with SEH, let's say. SJLJ, by the way, is set jump, long jump. So basically, x86 style exceptions on Windows 64-bit. So what threading API do you want? Because there's Win32 and POSIX, which is positively as good as this pun. And so the problem is that if you use POSIX, right, it's going to be slower because POSIX is a wrapper on Windows. And if you use Win32, you can't use things like std future because they didn't implement it. I'm not going to implement it. Screw that. But all these decisions affect how your Clang install will go because when you install this, if you chose the wrong options, Clang won't build because libstd C++ will have options disabled, or its error handling will work a different way than the devs expected. So you have to recompile Clang. We have any apps, like with standard library, which it's going to be libc++, right? Like I hope you aren't going to be using Clang with libstd C++ on Windows. Like you're asking for trouble there. So you're like, okay, what build system do you want to use? Well, you go and you ask on Reddit, right? And you're like, what build system can I use for this stuff? And someone says CMake, and there's a comment underneath that says, ha 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 ha. because you asked, is there something like Cargo for C++? So let's get into it. So you install CMake, and you start learning the CMake scripting language. Now I'm aware, yes, you could be using the command line and compiling like one file at a time, but at some point you're going to have to use a build system. So you start learning the CMake scripting language. A few hours have gone by. I'm sorry, what language are we working with again? Because this is like 4 slides in, and all the other ones were just 1 slide. And this is a colossal freaking disappointment. This upsets me. Because these other languages are drinking our milkshake. This is the whole pun that talk is built around. Because if someone said, hey, I've been writing dynamic programming languages for a while. I want to get into systems programming. I would not say, well, get started with C++. I'd say go use Rust because you're going to have a much easier time. And also, if you ever decide to move over to C++, you'll understand R values and moves, more or less, and RAII. I don't know how to pronounce it. RAI does not work for me because that's a bread. However, Haskell isn't drinking our milkshake because they're obsessed with burritos for some reason. Monads aren't a burrito, they're a sandwich. But C++'s complexity is further compounded by every tool that distracts you from writing C++. If you're new to C++, you shouldn't have to know the command line flags for a linker. You shouldn't have to know the command line flags for your compiler, especially because you're like, I don't even know what this means. And doing a copy paste and saying, don't worry about it, doesn't always work, because when you look at it, like, and you get an error, and you're like, why did this happen? And then you have to go ask someone, they're like, oh, you used the wrong command line options, and you're like, I was told not to worry about that. And I did hear someone say something about an IDE. IDEs are great if you're targeting one platform, but most of us, if not all of us, are writing cross-platform C++. So, a machine that squeezes bags of juice gets more time, money, development, and news than any of our tools. Juicero just closed down. They had, like, what, $400 million in funding? God, can you imagine what we could have done with that money? Instead of selling it to a bunch of rich Silicon Valleyites, or whatever you want to call people that live in Silicon Valley. Nerds, I don't know. But no one cares how the sausage gets made, what's in it, and if it's even edible. We're told to accept the state of things and focus on what really matters, right? Like if you went to your browser and you're like, I want to write a better build system for C++, they tell you to shut up and get back to work, right? And what your work is to stay late to fix the build instead of maintaining a work-life balance. Sorry, honey, I can't come home even though it's 3 a.m. CMake's acting up. What in God's name is CMake? The reason that I'm not home at 3 in the morning, and it's also why I drink. So instead of fixing the build system, we're expected to fix the build. How can we fix the build if we can't fix the build system? It's a sunk cost fallacy, honestly. Our build tools are missing the mark by a wide margin. This is the meat of the talk here. Let's hit the mark. Fix the build system. So modules. Everyone's excited for modules, right? This is not a rhetorical question, but okay. So if people on YouTube can't hear this, there was like a groan of disappointment across the thing. That's probably because you know that as you've been looking at the modules test, where you're like, wait a minute. And we're going to be talking about modules as they are in modules TS. They are a game changer. They change a lot of things, but not the way most people think. They're not a panacea. Panacea? Panacea? Thank you. I was going to make that cross itself out and say Panera Bread because I literally had never heard it said out loud. It's like, why? All right, why are these not that? Well, the build order is not automatically well defined yet. I had to put the yet there after I asked Gabby that question on the Girl Committee where I was like, we have to like manually define the build order right now with the current implementation of modules that are out there. And his response was, well, we'll make the build systems understand that. And then didn't elaborate on it because John Call said 2 sentences only. But also, there's no hierarchy for these modules, right? And that's a huge problem. Python, guess what? There's a hierarchy. Rust, hierarchy. You'll notice I'm not saying hierarchical because it's really hard to say that multiple times in a sentence. Haskell, hierarchy. They didn't used to be. Someone told me that they were not in 1998, but it's 2017. That was 19 years ago. Ruby, hierarchy, sort of. C++, shrug emote. YOLO, you only link once. So let me give you just a brief example. By the way, I lied. There's more code. I forgot. So this is not valid syntax what I'm about to show because you can't actually say modules multiple times. But you'll notice these are the 5 modules that Visual Studio gives you. Your file system, threading, memory, regex, core. Core is literally everything that's not mentioned in this previous 4, which seems like a lot, right? And you're like, okay, std.filesystem, std.core. I'm coming from other languages, and the dot is used as a separator. Of course. I know what I'll do to get all of this. I'll import std. There is no std module. Everything you know is a lie. You flew too close to the sun, Icarus. Okay, but really, Project Layout Ouroboros is responsible for this. This is how build systems have affected C++. And as a result, that's going to affect our build systems. Projects have these numerous file layouts, right? Which means modules needs to be quick and painless, more or less. So modules can enforce a hierarchy, file system or otherwise, even just like in a namespacing manner. And yes, I'm using namespace here, but not in the sense of C++. So build systems have to support all project layouts, which means build systems can't assume anything about a module's location, which means modules are only really for improving compile times and not reducing file count, because if anyone's been paying attention, you actually have to have an interface module, and then you can have your actual implementation module. Scott kind of spoke, Scott's right here, by the way, I'm pointing to him. He gave a talk on Monday, right, about the stuff at EA, and it was like, not good. Oh no. I should have checked the sizing here. Anyways, modules won't break the Ouroboros. But we do have this rare window of opportunity where we can fix our current build systems so that this won't be an issue later on. So we can fix the way we interact with them. We can change how our build systems understand C++. But it requires radical changes to our workflow and tools. And I'm not talking about a 360 indie nose done off of your make files. I was really hoping people were going to actually laugh at that joke, but I spent a lot of time crafting that. I'm sorry. It's disappointed. What else is new? So we need to change the status quo. And the first way we do this is with data over directives. This is really important. If there's anything you take away from this talk, and you are a build system implementer, please do this. Build systems are designed by programmers, right? I would be very concerned if one wasn't designed by a programmer and it was designed by marketing or something. So, as a result of this, because programmers like to program, they make us so our build systems have to program. And we get these domain-specific languages, some of which return complete, which makes no sense to me, because why does my build system need a while loop? Why? It doesn't. And our build system files consist of us directing a build runtime to do fairly simple tasks. Take this list of files, put this to the C++ compiler, or the generator, or whatever it is. There's no reason we can't give the build system metadata and then rely on directory layouts. Where's your include files? They're in a directory named include. I would hope that makes sense, right? Where are your source files? They're in a directory named source. Oh, well, there's this problem about globbing and whatnot, but even then, JSON, YAML, TOML, which is the least source of those three, you can have lists in those. You don't have to manually specify with like a set call and then set that as like a variable for another function call. There's no reason for this. Rust Cargo does this really well. Of course, they have a module system that's got a hierarchy, and also the whole thing is treated as one massive translation unit, but I digress. And if they need any conditional logic, they just put it inside an actual Rust program. You may say that that sounds terrifying. I'm downloading someone else's code and then I'm running it. Yeah, you should be auditing your packages though. But the best thing about this is that even though it's not the best approach, and they know this because you can't do post-build steps, you can at least debug your build, right? Oh, this build is failing. Why? Well, let's run it under the debugger. Oh, we're missing an environment variable. Whoops. Perfectly fine. And some people are probably going to say, don't do that with C++. It's a terrible idea. Because if you do, it's like, well, are you saying that because C++ is bad and it has problems? Which some people will say, well, yes, obviously. But I think it's more of because there's no ecosystem existing already for us to do that. But if you use an actual debugger, like you're not like using like Python's debugger to like hook into Python and then not actually get a good debugger. But using data definitions over a domain-specific language allows better tooling, because if it has a specification, it means I can write a tool that's not connected to your stuff at all. If you have a metadata layout that's documented, I can parse these build files, and I can do whatever the heck I want with them. Oh, we need to add some files? Great, I'll run this script that automatically knows how to add them to this file. Now, I don't have to open up a file and start editing it. We don't end up with these walled gardens anymore, right? If you use CMake, you have to use CMake. Calling out to another build system is a huge pain in the ass. Because if you've ever used external project add, you know that it's better to put that inside of a separate CMake file and then run CMake -p-e, someone help me out here, -s, I don't know. But you run it as a separate script, so it downloads everything first, and then builds it, and then your actual CMake gets run. It's a two-step process. Really shit. 15 minutes. So information about a build could be extracted without needing the build itself to run. So it also makes your nothing better tools, so it makes them a lot easier. You can actually have an upgrade path. So this is a small suggestion. I feel like skipping it, honestly, but basically build systems want us to list stuff out. Some commit globbing, that's bad. It's very divisive though. List directories at the most, right? It is simple. Every major OS directory works the same. Item in the directory is updated. The directory's timestamp is also updated. So it doesn't walk up the tree recursively, because that would be a bad idea. So we use a non-recursive glob in a directory. Check out the file names are the same. We don't actually have to check to see if the contents are the same. We just need to hash like a list of files. If they are, then you build the change files. If they don't match, regenerate the build. What about performance? Yeah, scanning directories can be slow, especially if you have like 100,000 of them, but why would you do that? Don't scan a directory if its timestamp is unchanged first. And also, which is slower? Editing a file that adds several files in the list and save it out, or letting a tool do that as like part of its run for like that was 5 seconds. No build system currently does the latter. I'd love to see some numbers, but you know. Yeah, well. But Goblin ends up with a lot of these like what ifs, right? Like what if we have 100,000 files in a directory? What if we use 10 different file extensions for headers? What if we add and remove a bunch of files in a directory a lot? Why are you doing these things? Don't prevent corner cases. When people act weird, like don't stop them because you get these what ifs. What if a user pulls in a bunch of white space changes? What if a user touches every file in our build directory? What if a user has a monolithic repository and millions of files? If they have that, they probably have a compiler team to deal with that shit. And then there's that. It's like a slippery slope, right? Scones uses MD5 hashes of a file content to see if they've changed. That's super slow. Like what cost? Progress means nothing if speed is sacrificed. But they're protected against incorrect timestamp changes. Can't fool that. But this leads to more what ifs. When you start doubting it. Wait, if my file's timestamps have been compromised, then what if my compiler's been compromised? Trusting trust. Have you ever read the paper? What if your meta build system's been compromised? Wouldn't be hard. Have you ever looked at the script files for CMake? What if your system make or ninja's been compromised? What if your Docker container's been compromised and this starts to escalate? What if the CIA is planning to kidnap you as you fly to Auckland from LAX on December 4th? What if Ted Cruz really is the Zodiac killer? Oh shit. So what if someone does have a corner case, right? Because your user interface isn't that great, make a better UI. They need to organize their code, change nothing. Small hack, once given, cannot be taken back. Your build system does not have to adapt to someone else's worldview. This is how we get project layout Ouroboros. And just because something exists doesn't mean they have to use it. This happens a lot in open source where someone's like, you need to make this change. And you're like, I don't want to. And they're like, how dare you, sir? This free tool you've given me. I demand more from you. It's ridiculous. These are the questions you need to ask. Will this corner case require form to come before function? Will this enforce the Ouroboros? You don't want to be part of the problem, trust me. Will this improve existing users? Not potential converts, people that don't exist yet. Will it improve their quality of life? And does it reduce the workload overhead of users? So, demons, we're actually going to skip this. This isn't that important. And if you want to ask me about this, I will show these slides later. But basically, build systems shouldn't run as build systems in the background. They should run as generators in the background. However, if you try to save a file while a build is running, you deserve to be punished for hubris. Okay. And we're also going to skip this because this is like real quick, but you have different CPU architectures, aka dash March Madness. I'm glad. Okay, thank you. Someone told me that wasn't funny, and I was like, okay, you just don't watch basketball. But you end up with these ABI issues. If you're like trying to like, you know, worry about exceptions and stuff like that, it can be a problem. And there's incompatible code generation options too. If you ever see a C library use -02, you can bet your butt that they are using it because -03 is going to enable optimizations that remove undefined behavior, and then things broke, and they're like, well, 02 works, I guess I'll just ship it. And you end up with undefined behavior breaking your code generation options. There's also transitive linker and compiler flags. I will show you an example of how we can possibly fix that. And like, dude, there's a lot here, right? Like every build system has to know how every single compiler and linker works. Okay, phew. Apparently I just tried to do a bunch of slides in 5 minutes, but we'll do. So, but reproducible builds with this issue, like this is, we'll get to this in a hot second, because this is technically a pipe dream. This tool doesn't exist yet, and I haven't had time to actually write it because of other issues that I don't want to talk about right now. Dependency management without package managers. A lot of build systems will start to use package config. Meson uses it, CMake uses it, Build2 uses it. They all generate them too. It's insufficient for the needs of C++. What is up with this formatting? It was working fine earlier. Put that in quotes and then quote me on that because that's like literally software. So what's package config? All right, it's an open source tool with Windows support as of like a few years ago. People don't know this. There's Windows builds and it can interact with the Windows file system and like supports spaces in the file names and in directories. Like that's a really big deal for a Unix tool, trust me. It's written in C and it's written for C. And this is a big problem, because C and C++ are not the same language. But it provides an interface to query your compiler and linker flags for a library that you constructed. So what does it do? Well, I just mentioned it, but when it actually does an operation, it searches the directory for a file named libname.pc. It opens the file, it reads the values, which are just key value pairs more or less, and then puts them listed out. It's super simple, but it has a guaranteed format. It's part of the whole free desktop specification thing. So why is this a problem though? It doesn't support multiple versions of the same library. If you want to have GTK 2.0 and GTK 2.1, yeah, go screw yourself. It's not going to happen. And if you want to have like a debug build and a release with exceptions and a release with bug signals and without RGTI, all on the same system, nope, can't do it. There's no virtual environment path setting, so you can't say, look in this specific directory for all of these files. And it wouldn't matter even, because if you had multiple libraries that you need to depend on in different versions, it doesn't solve the problem. There's no protection against incompatible compiler options. So if you want to use -march i7 and you want to use -march, I don't know, Atom, why would you do that? Wanted to stop you. I don't know if GCC actually errors on that, but it should, probably, if it doesn't. But we can solve this. It's the same problem as before. We'll get to that. So how to fix it? Oh no. I definitely forgot to close something on the HTML file. Now I'm being punished for my viewers. So we can write a better tool than package config. Oh, that's what happened. This is embarrassing for me, I'm sorry. We can write a C++ aware package config. I would actually recommend against this, but there is a comedy option. We can move to the desert and go Texas for a living and give up on tech entirely. So there's this concept of option comprehension. Build systems don't know what a compiler flag is. They're all strings. In every build system, it's always a string. You think your compiler, or rather your build system knows what -march means? It does not. So, real quick, what is a compiler flag to enable all warnings for Clang? It's everything. For MSVC, it's actually /wall. For GCC, they don't have one, and they don't want one for some reason. Because what if they add new warnings? What if? So here's a harder one, right? That one's really easy to find out because you can find that in Google search. What's the compiler flag to enable warnings for virtual function hiding? Right? For Clang, overloaded -virtual with the -w flag. For MSVC, I don't know. It's like 4307. It's got a number. It has a number. Good luck finding it though on a quick Google search because I actually couldn't find it, and I believe it's actually like 4 or 5 settings altogether. GCC is the same as Clang, but it works a little differently. This is the problem. Every build system must either comprehend every possible flag and provide semantic understanding for each option for each compiler it supports, or treat compiler and linker flags as strings and help the user know what they're doing, which you don't. I guarantee it, because it will always get messed up, and you'll be like, oh, why is our forgot it. Right. This isn't supported by this version of GCC. My bad. But the burden of incompatible options is the responsibility of the user. So close to more than 5 minutes, please. So, how do you let the user know they built something with exceptions enabled and a dependency that has disabled them? You don't! There's no build system that does this. But we can solve this. And if anything, this is the easiest problem to solve. This is the pipe dream. We need a universal compiler interface. This sounds crazy, right? You're like, hold up. Compiler interface that wraps every other compiler? Yeah, okay. But anyone's going to use that because now build systems no longer need to support every compiler. You have a de facto CLI for tools and users. You have cross-compiler support. You don't have to worry about, is this a monolithic compiler where I have to make one for each target that I'm targeting, or is this just a compiler that targets multiple platforms? Supporting new compilers can be just a configuration file. Aha! You say, build systems will have to support your interface in addition to other compilers, so you've solved nothing. Allow me to link that XKCD comic about multiple standards or whatever, so that you may wallow in despair as you pay for your hubris. No need. That's entirely false. We've not made a new standard. Nothing stops the build system from hiding this from the user. The de facto CLI, you don't have to memorize flags for different compilers. Enabling any language TES becomes the same where it's enabled. The tool knows what these options mean for each compiler. We could do overloaded-virtual equals true in a file and pass that to this universal compiler interface. I don't care what MSVC's flag for that is anymore, because it's just a lookup in a dictionary. We have better cross-compile support. Some compilers have multiple instances for each platform. Some compilers are always cross-compilers. Why should anyone have to care? Added support for new compilers. Handwritten configuration file. Or you can do automatic compiler detection, which every build system has to do already. AutoTools, Muson, CMake, they all do this. We probably need an automatic toolchain manager of some kind. Mainly updating DCC or client outside of your package manager is a huge pain in the ass, as I demonstrated earlier. Pretty nightly builds with Clanger GCC is even worse. If you want to have like a nightly update, like, I don't even have words. There's no reason we can't trust someone like Google or Facebook or Apple or Amazon or Microsoft or like Qualcomm. I don't care. Someone, anyone that we can like moderately trust, to not screw this up. Which, all right, fine. And checking Stefan's website doesn't count as like, oh, you know, let's see if the HTML files change. Don't do that. So I don't have any suggestions for this other than don't make it bad. Quoted. So some takeaways for this talk. Remember, build system's form must follow its function. Modules are for you, but not for your build system. At least the modules TS. Your user's hubris should punish them, and it's not your fault. It's like the Goodwill Hunting saying. It's not your fault, Will. It's not your fault. Our ecosystem is garbage, but we can make it much better. We just try a little hard. I did want to talk about an actual build system and package manager combo, but after Titus's talk yesterday, I wanted to reevaluate that, and I don't know, maybe there will be a sequel to this next year. So, we're at the end of the talk. I think we're almost out of time, actually. You know, tell me. Yeah, where are we at? 2 minutes? It's enough for one question. If you have it, please get behind the microphone. It's not a question, but okay. No questions? What's that? Yes, there is hope. What's that? What? It's in you. It was in you the whole time.